Okay, sorry, I got a phone call. خلاص, I put it on airplane mode. For this inequality, I would just remove this and that and say x plus 2 is greater than or equal to 6x minus 3. So I can just take this there. I'm gonna say 5x is less than or equal to 5. So x is less than or equal to 1. I'll just write it this way. I prefer x on the left side, less than or equal to 1. Okay, you will have to ask yourself, is there any problem of leaving that without assuring that here I would never get a negative and here I would never get a negative? Okay, if I start substituting here 1, there's no problem. But if I substitute 0, I'm gonna get negative 3. Negative 1, I'm gonna get negative 9. And also over here, less than or equal to negative 2 would start causing problems for me. So I have to keep myself safe. How keep myself safe? Take this and say x plus 2 must be greater than 0. This is what I know about logs. And 6x minus 3 must be greater than 0. So this one, x is greater than negative 2. And here, x is greater than 3 over 6, which is half. Which number is bigger, negative 2 or half? Half, then I would use this one and I'll not take the smaller one, okay? So I will say that x is less than or equal to 1, but x is greater than half, because this tells me x has to be greater than half and it's not accepting any numbers less than that. If I take this and say x is greater than negative 2 and I put it here, that negative 1 will cause a problem over here. So I'll take the bigger number and just plug it to the left side to make sure I would never get a negative in both of them. Okay, I will repeat again. For question, for example, let's say question number 31. Log base 5. 12x plus 5 less than or equal log base 5. 8x plus 9. Okay, so directly I would say 12x plus 5 is less than or equal to 8x plus 9. So 12 minus 8, then I'm going to get 4x is less than or equal to 9 minus 5, which is 4. So x is less than or equal to 1. Am I safe? If I put a negative number over here, for example, let's say I put a negative 2, I'm gonna get negative. And over here, I cannot proceed with negative numbers because x's are positive over here. So I'm gonna say then 12x plus 5 has to be greater than 0, and the 8x, just to keep myself safe. So this one will be x greater than negative 5 over 12, and this one x greater than negative 9 over 8. Definitely this is bigger than this because this is 1 point something, but this is negative 5 over 12. Negative 5 divided by 12 is negative 0.416. Okay, and negative 9 divided by 8 is negative 1.125. And I want the bigger one, and the bigger one will be less value. I mean the bigger one on the number line, the one that's on the left side. So definitely this is negative 9 over 8, but here is negative 5 over 12. I go for the bigger number and just stick it over here. This has to be greater than negative 5 over 12. Okay, so that's it for this lesson. I will go to properties of logarithms in lesson 7.5. Lesson 7.5 has some properties of logarithms. Okay, and from these properties, the product property, which we know, product log base xab is equal to log base xa. Remember, product changed to plus, and this is also in the precalculus where we expand. It's here in the algebra, but it's more advanced, I think, in the precalculus book, so I'm going to get you some questions from there. So it turns into a plus, and this is product. I would directly write the quotient rule. It's log base x a over b equals log base xa minus log base xb. And there is a power rule. Okay, the power rule says if I have log base b m to the power of p, I'm able to put the p on the left side. So p log base b m, where of course over here b cannot equal to 1. So I can take the p to the left side or bring it according to what I want. Okay, we did in pre-calculus expanding and condensing. This is all expanding, and to the left side I'm trying to condense. Okay, so over here, these are the properties in this book for this part. For example, solve each equation اللي هما question number 23. Solve each equation and check your answers. Log base 356 minus log base 3n equals to log base 37. Okay, and let me open my pre-calculus book. I'm gonna get you questions from there as well when I'm done. So over here, since this is a minus, I can change it to a division. So it will be log base 356 over n equals log base 37. And this is called condensing, okay? Now I can remove the logs and say then 56 over n is equal to 7. So 7n equals to 56. So n equals to 8. This is 23. 24 has a plus, so I have log base 2 for x plus log base 2 5 equals log base 240. Instead of the plus, I can say I can condense it into log base 2 for x times 5 equals log base 240. Now I can say that 20x is equal to 40, so x is equal to 2. Of course we can factor. Sometimes we will need factoring. I think in question number 26, let me display this one. Plus log base 10a plus 21 equals to 2. This is a case where I have log on one side and there's no log over here. There are no log. Okay, so my only option is to go to exponentials. But first I will use the product rule to say that log base 10 a times a plus 21 is equal to 2. And then I'm sure that a times a plus 21 is equal to 10 to the power of 2. So a squared plus 21a minus 100 is equal to 0. So a and a, 100 I would go for 25 times 4 because I have a 21 over here. So 25 times 4, and 25 is positive and 4 is negative. So a might equal to negative 25, or a might equal to 4. But a cannot equal to negative 25 because here I cannot put negative 25, nor here I cannot put negative 25. So my only answer is a equal to 4. Again, let's say I have question number, okay, 25. Let's say I have 5 log base 2x equals to log base 2 32. I can first of all take this to the power. So log base 2x to the power 5 equals log base 2 32. So x to the power 5 is equal to 32. Which number, or I can think directly that it's 2 if I'm in the test. Let's say x to the power 5 equals 2 to the power 5. So x is equal to 5. X is, sorry, it's not 5. X is equal to 2. I'm sorry, since the powers are equal, then the bases are equal. So x is equal to 2. Okay. Another option, for example, question number 37. Log base for a plus log base for 8 equals log base for 24. So directly 8a equals to 24, and not 8 plus a, it's 8 times a equals to 24. So a equals to 3. Okay, by question number 41, I have 3 log base 10 8 minus half log base 10 36 equals to log base 10x. Type, I'll take this as a power here and this as a power there, and I'll change this to a division. So it's log base 10 8 to the power of 3 over 36 to the power of half, which is root of 36, equals to log base 10x. Okay, 8 to the power of 3 is supposedly 512 over, I'm gonna cancel the logs, this is root of 36, which is 6, equals to x, and 512 divided by okay, you're going to end up into 85 and 1 over 3, or 256 over 3. This is the final answer for this question. Okay, let me check some questions from the pre-calculus book. In the pre-calculus book, they asked us to condense in chapter 3, I think, condense and expand. This part was not exposed much in the Algebra 2 book, right? I think we're in chapter 3. Just give me a second. We didn't discuss yet len and e. I'll make another video for that. Properties of, yeah, it's called 3.3 in the pre-calculus book. 3.3 in the pre-calculus book. 3.3 from the pre-calculus book. It's called properties of logarithms, and they displayed the 3 properties that I just said, the power and the product and the quotient. Okay, and over here, for example, evaluate. Okay, my pen is okay. I'll go to the expand each expression. For example, question 29, they said expand log base 9 6x to the power 3 y to the power 5 z. Okay, how will I expand? And I have here 6 multiplied by this multiplied by this. Expand, remember the rules when we said we expand. If we have a multiplication, we change it into a plus. If we have a power, we take it as a product. If I have any power, I'll drop it down, and if I have multiplication, I'll change it into a plus, and if I have division, I'll change it into a minus. These are the 3 things I do when they say expand. Okay, so I'll write with my pencil. So I can expand this into log base 9 6 plus log base 9 x to the power of 3. If you wish directly to put the 3 on the left side, you can do that instead of wasting your time. I hope this pen is working. Okay, plus log base 9 y to the power 5 plus log base 9, and don't forget to put the 9 every time. You cannot leave it like that, those. So the final answer is log base 9 6 plus 3 log base 9x plus 5 log base 9y plus log base 9z. See how much we expanded? And it was one expression, and I made it into 1 2 3 4 terms. Okay, another example is question number 30. Question number 30 gave me len. Len is just a log with a base e, if you still remember. X plus 2. Okay, so division, I would change it into a subtraction. I can say that it's len x to the power of 7 minus len x plus 2. Okay, over here, if I have a root, I would change it into a power. Okay, add it to these. If I have a root, I'll change it into a power. So x plus 2 to the power of, this is supposedly 1, so 1 over 3. I'm not done. Why I'm not done? I cannot leave powers if I'm expanding. So I'll drop this 7 over here. It will be 7 len x minus 1 over 3 len x plus 2. And this is the final answer, and I cannot split the x plus 2 because they're not multiplied by each other, they're added to each other. So I'm going to leave them alone. Question number, let's say question number 33. Log base 11, a b to the power negative 4, c to the power of 12, d to the power of 7. Okay, first of all, I say it's log base 11a plus log base 11 b to the power of negative 4 plus log base 11c to the power of 12 plus log base 11 d to the power of 7. صح؟ خلاص, this one is done, log base 11a. But this, I'm gonna drop the negative 4 here, so it will become a minus 4 log base 11b. I'm gonna drop the 12 here, so it will be plus 12 log base 11c. I'm gonna drop the 7 here, so I'm gonna have plus 7 log base 11d. And here is the final answer for this question. Okay, this is somehow kind of how we expand. I'll do a couple of questions on how we condense. Everything is the opposite from what we said. So if I have an addition, I'm going to change it to multiplication. If I have a subtraction, I'm going to change it to a division. If I have a power, I'm going to change it to a root. And if I have a product, I'm going to change it to a power. Okay, so I'll do opposite of all what I was doing. For example, question number 39. I have 3 log base 5x minus half log base 5, 6 minus x. Okay, between them I have a minus, and here I have a product that I will take as a power and a product that I will take as a power, and definitely this one will change into a root at the end. Okay, root, because the power of half is just root of square root yani. Okay, so question 39, I can say that the question became log base 5 x to the power of 3 over 6 minus x all to the power of half. Okay, because I'm going to change the minus into a division. So log base 5 x to the power of 3 all over root of 6 minus x. And this is the final answer after condensing this question. Question number 40, for example. I have 5 log base 7 2x minus 1 over 3 log base 7 5x plus 1. Again, power, okay, to both of them, to 2x, and here power to everyone here. I think I'm going to end up in a root, and this is going to turn into a division. You will write log 7 once, and this is 2x all to the power of okay, type question number 40. Okay, to the power of 5 all over this is 5x plus 1 to the power of 1 over 3. So I can still move on. 2 to the power of 5 is 32. X to the power of 5 all over cube root of 5x plus 1. And definitely we can work on multiplying to try to rationalize the denominator or to remove the root. I don't think we'll go so deep in your test to this extent. I'll get you one that's an addition, like question 45, 2 log base 6 5a plus log base 6b plus 7 log base 6c. Regarding question 45, take the 2 as a power and the 7 as a power, and all the pluses are just changed to a product. So I have log base 6 5a to the power of 2 times b times c to the power of 7. Still, log base 6 25a squared b c to the power of 7. I have question 44. It has a plus and minus, and I think I'll stop over here. Question 44, len 13 plus 7 len a minus 11 len b, so I think this will be a division, plus len c. Okay, this 7 will come as a power, this 11 will come as a power, so I can think about this question as len 13 times a to the power 7 times c. I would just write len once, divided by b to the power of 11, and I think this is the final answer. Or you can write it as len 13 a to the power of 7c b to the power of negative 11. If you took this as a negative 11 as a power, also this is a possible answer, and this is a possible answer according to the choice that you have. Okay, I will I don't think I have more to do here, so I will stop here and then do another video later. Bye.